Hello, I'd like to welcome everyone to the first lunchtime chat we'll be hosting in our new mini-series for EPCs called Exploring New Possibilities. Today's discussion will be all about Select.io. My name is Crystal Futter, and I'm the Marketing Communications Manager for ABB's Energy Industries Division, and will be the host for the entire mini-series. Due to the high number of attendees, everyone's microphones have been muted, but if you do have a question, please enter it into the Q&A box on the right-hand side. They will be all addressed at the end of the presentation. If you missed part of our webinar or would like to share it with a colleague, or even better, watch it for a second time, we are recording the session and will make it available in our Exploring New Possibilities and EPC mini-series webpage. I'll share the link in the chat section so that you can bookmark it to register for future sessions and watch on-demand recordings. And now, without any further ado, I'd like to welcome Rory Tanner, ABB's Product Marketing Manager for the System 800XA.
Well, excellent. Thank you very much. So yes, this topic that I'll be covering is on Select.io and extreme engineering, some best practices and how to do projects better. There's three main topics that we're going to be covering here, or points of value about Select.io. Is how it supports parallel execution. So project tasks can be done in parallel to remove automation off the critical path. It'll minimize the impact of late changes that occur in a project to reduce project costs, and it's going to promote standardization, a better approach that can also reduce project costs. So we'll be covering these three items. A little bit about myself. I am in product marketing for the process control platforms here at ABB. Over 30 years in automation. Started with Taylor Instruments, if you will, back in the day. But a couple of relevant jobs that I've done over the years is I was a project engineer, a lead project for various DCS projects along the way, as well as I worked for an end user, and we did initial startups of a facility, as well as we doubled the plant size and did a whole full-blown project for that in my past here. For actually, it was for the automotive industry, making airbag propellant and things. So we've done quite a few. I've done quite a few projects over the years, and so a lot of this topic that we'll be talking about is kind of close to the heart because I've lived some of these issues that we're going to be talking about. A little bit. So before we get into what is Select.io, this I/O system that we wanted to talk about, I want to talk about what the issues are of where this came about and what this really helps. And if we look at capital projects, studies have shown over and over that capital projects run over budget and experience delays over time. And automation is that last thing, right? It's critical to the end of the project where everything kind of comes together before you start a production. It has to be done. So it's always usually on the critical path to project completion and getting that plant up and running. But if you think about it, automation projects have been run the same way, basically, for decades. My colleagues and I that maybe started right out of school with these automation companies were taught a certain way to do projects, and really it hasn't changed too much if you think about it. So one thing, if we look at that way things are executed, why hasn't it changed in the past? So that's the thing. I think when we look at these, some things needs to change in order how we do this. We have the technology now. We have a lot of capabilities. The means are out there, so this is what I want to present to you today. But let's look at the problem of where this came about. So let's look at that traditional project that I talked about. So where do we start? We usually have to do design work, right? So we'll coordinate with EPCs or from a vendor perspective, from whether it's a small project or large project, there's some kind of design work that has to go in front and to finalize that design documentation. And as soon as we do, what we want to do as a automation vendor is do a design freeze. We have to order parts. We have to order the hardware, get those in as a project lead, and build those cabinets, get things started while the software configuration is going on. And also along the way, we have to, maybe configure I/O, but it brings up changes that might occur along that scope. So that early design freeze kind of is a little bit of a pain for EPCs, that maybe we didn't have all the information kind of together at the beginning of the project. We did the best we could, of course, right? But sometimes it's a little early on. So there's changes to that scope. So maybe there's more I/O, where some of the I/O has changed from, let's say, analog ends to digital ends. Maybe now it's it used to be a field bus communications or something, but now it's actually turned out to be hardwired. So there's all these changes that might occur, and what that's going to result in is change orders, because now those cabinets that we're building have to be changed. Maybe there's an additional cabinet, or maybe things have moved. So now we have to do some rework on that cabinetry. So that's where those change orders come in. Finally, though, we want to get to a point where everything's together. The software configuration's there. Let me get a pointer going here. So we want to get to a point where we do a factory acceptance test. That means we have to have all the hardware going, all the controllers and I/O, and we have the software there. And that's when you come in and we do all those checks and everything else, whether we're going to check 10% or 100% of the I/O and simulate things along the way, and we try to get that going. Then we have to ship it to site. Then we have to ship it. It has to get installed. If you think about all the things that have to happen before we can even do loop checks, all the equipment's got to be installed. It has to be wired up. We need the system consoles in there to do some of the loop checks. You want to check it all the way through, and usually you have an operator there in front of the console with a radio. You got a field tech out there that's moving some of the equipment or some of the limit switches and all the maybe jogging a motor to make sure that things are coming all the way in through to the system, and they check out all the wiring all the way through. So all this equipment has to be kind of installed before that can even start, as well as everything has to be wired up and checked out. And at that point, now you can start doing some loop checks and start doing your startup, your commissioning activities. And it's a very dependent approach. If one of these things is late, the whole thing is kind of delayed along the chain. If the equipment is late to be installed, well, we can't start doing the wiring's not done. We can't start the checks. So you can see where it's really susceptible to having these delays over time. So what we rather do, though, is try to have a more parallel project approach, where we kind of alleviate those hard design freezes and things like that. So if we can do this kind of compressed parallel execution, we can alleviate a little of the pressure up front, where we give maybe more time to get our act together, right? More time to make sure that design documentation is fully baked. Maybe we don't even have to start doing a lot of the coordination. So for later when things are worked out. So immediately, if we can have a little more time to get our act straight, well, that lessens the chances for these late changes, right? And these maybe things that would impact and maybe have some impact on change orders and things. Well, maybe they never come about because we fixed it in the beginning. So there's a little bit of alleviation there by trying to do a parallel approach. But the design it has to be done at some point, but we like to split off between the hardware and the software configuration. So if we look at the bottom row here and the software configuration, so the software configuration is done from the design documentation, but it's done in a way where we don't have to assign all the I/O. Let's say we're going to use some, the names for things, for instance, it'll be signal names and so forth. But the idea is that we can do an application factory acceptance test. We can simulate now all of that logic and everything that's done, so we can simulate to make sure the software configuration is going to do what we wanted it to do. If you look at the top level, though, we wanted to do the hardware a little different, where we can actually take and we don't have to get all that hardware initially purchased and build all those cabinets. What we want to have is more of a standardized approach and have standardized cabinets that can be kind of morphed into whatever. Like the I/O doesn't have to be installed till later in the project, more of a late binding approach. So we can take these standardized Smart Junction Boxes, is what we name those, and place those near the equipment. So immediately you have a lot of less wiring to do, a lot less cable runs, less to define up front, and the I/O comes in. But at the time where you need to do the equipment connection to the equipment and do your loop checks is when you can purchase and install the I/O modules. So now you've got a lot of time to work out all those details that you couldn't probably even have known maybe at the beginning of a project in the traditional sense. So now you don't even have to buy the electronics and I/O until you're ready to do the loop checks. And then you install those in the field. And now there's ways to do a lot of loop checks and functional loop checks in the field without having the controllers, without having any of the infrastructure that you normally need, including the consoles. You can even do those now all from one laptop. You can connect to hardware and do all those checks. So now you can do a lot of the hardware configuration and check out separately and do all those functional loop checks to make sure everything's working correctly. Once the software applications are done, you can bring those in, and that's when you can bring everything together in a late binding approach, and it all kind of connects, and then you can start your commissioning. So the idea is this really can alleviate some of those pressures and those hard design freezes to kind of what we say is take the drama out of the automation projects. Another problem that we see, that we've kind of noticed over the years, is all of our automation connectivity in our projects are all controller centric. So if you notice, you have a controller with I/O modules off of some kind of bus or some kind of daisy chained or arrangement, bringing up into the CPU, that processor that's going to process the logic. And those are separate. So remember when we looked at that traditional project, when you have these items kind of separated and they're brought up to there, if you do have to make those changes where maybe this I/O is now needed over on this processor instead because of the changes you made, you're going to have to do some rework. Another option is sometimes when things are brought up to one controller, sometimes people will then move it over via software. That creates a lot of more overhead on your CPU, so they can do less logic, and because they're handling communications of points from one controller to another. And later in life, that gets really messy when you're trying to debug things and trying to do startup and so forth. So there's that kind of created that problem, and that we call that more of a controller-centric, arrangement, because that rework can really spawn a lot of change orders and things. What we wanted to try to get to, and what Select I/O allows us to do, which we'll see in a moment, is more of a network I/O solution. So this is on an Ethernet network backbone, where the I/O is placed out there in those standardized cabinets. And if a certain I/O module that comes in is needed to go to a different controller, well, it's already on an I/O bus, so really you don't have to make any changes. Now the controller that you want that I/O in just needs to go access that I/O instead of the other controller. So really you don't have to make any hardware changes. That means there's no rework, there's no need for change orders. We've seen that in projects quite a bit now, where changes don't really have the impact that they used to when you're using an arrangement like this. So there's a couple key concepts. That dependency-driven kind of model of how you do projects, and this controller-centric really kind of spawns those problems, and we've alleviated that with what we call Select I/O. So let's look at that. Select I/O is a single-channel granular, late-binding Ethernet I/O solution for ABB's System 800XA automation platform. So that really helps us decouple those project tasks that I showed you earlier to optimize project schedules. It minimizes the impact of late changes because you have a lot reduced. First of all, you have a lot more time maybe to get your act together, so you don't have those inconsistencies. And if you do, they can be accommodated for because of that networked I/O solution, for instance. And not to mention, this is a single channel granular, so if you have to make changes, it's really only on one module. One instead of an entire multi-channel solution, and reduces wiring costs. That standardization approach that we talked about, or that having standardized cabinetry, really is one of the key components to realizing the value of something like this. To have that standardized approach reduces documentation, overall footprint, and other items. So just to kind of give you a little bit overview of what this really is underneath the hood. When we talk about Select I/O, there's the head station, if you will, the communication. We call this an Ethernet field communication interface. This has redundant communications, either copper or fiber, built-in, a built-in switch so that we can just plug into it with a laptop, for instance, when we want to do some of our configurations. It has redundant communication interfaces, redundant power inlets with the voting inside. Connected to it is module termination units in here. These module termination units is where you plug in things like what we have, a generic I/O module that's basically like a 16-channel I/O module. But then we have 16 conditioning modules, signal conditioning modules we call SCMs. Now this kind of formats the signal coming in, and then it's communicated to this GO, we call it, just generic I/O module, and then gets communicated to the controller through the FCI here. But you notice all the wiring, there's grounding bars, things like that, external power injection for signals like digital outs that need extra power. But other than that, all the power is run through the backplane for the IOs, other than the ones that need external power. So you have a lot of capability all within this. You can have up to 12 of these MTUs tied to one head station, right? So 16 times 12 IO per head station. And you can have a number of Ethernet FCIs just on one controller. I mean, over 100 FCI stations, for instance. And it's all on a separate networked IO bus in an Ethernet-based backbone. All of the hardware is based for temperature ratings like minus 40 to 70, so it can be out there without external cooling and things like that, or heating. So the idea is this is kind of an all-in-one and really perfect for that standardized approach, which I'll talk about later. But these are the essential components between here. We have things like in between channels, we've done a lot of features so that you negate the need for ancillary hardware, meaning I don't want to have things like extra wiring terminations that might come up, So we'll talk more about the individual signals and what's available in a moment here. But each field terminal block here is programmable for the modules that go into it. They get configured, which we'll look at now. So those signal conditioning modules, really, what do we have in there that will have different types of modules that get to be plugged into that base, basically, depending on what signal you have. And they all get plugged into a removable terminal block that is keyed. That gets keyed. You can notice on the right-hand side here, this middle section is a key. And that sets into the terminal block what kind of module it is, so that if you do replace it, it has to be the same type of module. But this can be reset very easily without removing the terminal block. You just have to jog it a little bit with a screwdriver, resets it, now you can put in a different module. So if you think about when you wanted to change from a analog in to a digital in, let's say late in the game you find out, oh geez, I thought this was going to be an analog, but it's a digital. Really all you have to do is take the original module out, jog it, put the new one in, and there you go. As they say, Bob's your uncle. Now the IO that's coming in can be routed to that IO module, and it's now that type of IO signal. So really there's no change order needed when you're doing things other than buying the new module, right, to having that on hand. There are different modules for SIL3 applications. And one thing is there's even additional modules for sometimes things like gas detectors and other items, let's say in a colder climate, have built-in heaters, and sometimes they need additional power. So one thing that's nice about having a solution that has these different signal conditioning modules, if you have a need for a certain application, we've created a module just for this that allows you to have extra power available, extra current available to that gas detector, for instance, when you need it for the internal heater and things like that, all without having to add any additional hardware. All you have to do is switch out the module. So that really kind of negates the need for extra wiring or extra changes that have to be done to those standardized cabinets. And that's really the key to this. One thing I didn't mention also, if you look, there's a cardage connector. It's not a pin-based connector. So these things are made to be put in and out. So it's not one of those things where you can get bent pins on things. So it's a pretty robust design on there. Also for like IS application, for intrinsically safe applications, usually you have to add extra barriers, and that really takes away from the overall idea of having a standardized approach, right? So if you had to change to a IS module, or we have ones that have built-in barriers into the same form factor, so we don't have to add external hardware. So if you do that, well, guess what? I'm going to have to do some cabinet changes. I'm going to have to do some wiring. Again, that's rework. That's going to be a change order. So by having it all built in and the terminal blocks removable and replaceable, you can change over a whole MTU to an IS MTU without removing the base plate. So that really helps out in the long run. And we have also SCMs for with IS applications for intrinsically SIL3 applications. And there's some specs on the left. You can find out more. I'm going to show you where to get more information on all this in case you have any, or you can ask me at the end of this presentation if you have individual questions on things. But there's HART capability. All this is line monitoring built in. Everything's current limited on these. So again, it's all about negating the need for this ancillary hardware. So I don't need those fuses anymore. I don't need maybe separate HART communication devices. It's all built into this I/O system. One key thing I wanted to talk about is the field disconnect mode with this. We have there's 3 modes. We could have it basically plugged in and powered. We can have it remove power from the field and be removable. There's also a middle one where it locks out the module from the field with an air gap of 5 millimeters. But it is also on the other side. You notice on here there's 2 sides of this. One side is to the field, and by removing the module a small gap, and it's locked in place into what's called a field disconnect mode, the other side is still connected to the system. So I can still look at the module, I can still program the module, make sure it's okay, but it's disconnected from the field. And this has proven a lot, or very useful in startup situations where maybe certain signals aren't commissioned yet. Maybe they're not checked out. You can put them in this field disconnect mode. Nobody can bump into it to push it in. It's in a locked state. And then when you're ready to do that loop check and do your commissioning, you can then push it in and do it. So we found a lot of people coming back to us when we're doing projects saying, hey, that really saved us. That really provided a really nice workflow for when we're doing commissioning. And one thing I want to talk about is these standardized smart junction boxes, which they can be built per project, if you will, but we also have them standardly available that you can buy that are already pre-designed, pre-baked. But we have had people do both. They buy them either from us or they can build their own per their project, per their requirement specifications. But the value is still there because you have a standardized design so that you don't have all those different let's say loop diagrams, right? They're all standardized. The cabinet itself is standardized, and there's really not a need for deviation between one cabinet and another because of the capabilities of the I/O system. If you probably certain competitors might have a similar offering, but if you looked at the details, if they have to, if you add IS, for instance, and then they have to add barriers, and then you have to wire, even if it's a prefab connection, it takes up more footprint. There's changes to the cabinet, therefore you're going to have to change the documentation of that cabinet. So the more standardized approach you can do, you can remove all those documentation nightmares, if you will. The individual loop drawings go away. A lot of the I guess the individuality of these cabinets that we have out there kind of goes away. And again, that's one of the big advantages of having a standardized approach. But if you look at why is Select I/O so good for the standardization, the head station has options for fiber, built-in fiber with a built-in switch. So they don't really need any kind of external hardware when, if you see here, when you're communicating, you don't need another, for instance, switch in the cabinet, if you will. The power inlets, they have built-in diode auctioneering. You don't need to add that external hardware, any kind of voting hardware. Isolators onto. You have channel-to-channel isolation built into this I/O system, so you don't have to provide, do those, have a separate terminal block with isolators and all that in there and all that extra wiring. That's all put in place. Fusing is required because of the current limiting. The power is kind of brought down through for the I/O like an analog transmitter and kind of brought through the backplane, as well as there's power injections for those that need the extra current for those higher current applications and safety I mentioned, or digital outs, for instance, that might require more power. Those are injected from the side, so you might have an extra set of power supplies dedicated for those type of applications. And also, the idea is you can change the modules without any footprint changes. So changing from an AI to a DI, that is no different. Changing to an IS signal, for instance, there's no added footprint to the I/O solution. And there's no added backplane that you have to put in or some kind of sub cabinet or something and wire to. It's all built into those SCMs, those wires, those signal conditioning modules that we have. So that's really what it was designed for, to put into the standardized junction boxes. And those junction boxes would be then located as close to the equipment as possible to reduce down all the wiring and other costs that you have. But really, I think some of the things are overlooked. With this, the whole value wouldn't be complete without some kind of software application that we can do with this. One thing that we've come up with is an Ethernet I/O field kit. Now, this field kit is on a laptop, let's say, or a tablet, PC, and because of things we've done with this Ethernet I/O field kit in in our Select I/O offering, we can basically plug into that head station with one laptop. And this allows us to do all the things that we would do with that full system that had to be installed in the past. So what we can do is we can actually scan what's in the I/O and configure all that hardware, because we wanted to separate out the hardware configuration from the software. So with this field kit, we can then configure all of the hardware in the system. We can actually build a test application automatically based on the I/O that's in that standardized cabinet. And we can also then do our functional loop checks with that. We built into the system all of the human-machine interface, all the HMI capability to look at faceplates and look at the I/O all the way through to make sure that is reading, that it's configured correctly and it's reading what it should. All without the software application, all without controllers or field bus communications. We've done all that in a kind of a virtual or a soft arrangement so that you can do all that work before the system actually arrives for installation. That allows you to really free up and do that when the equipment's available, when you're ready to go, and the I/O is installed. You can then go and check that out in parallel of everything else going on. And once you're done with the configuration, that's when you bring it in to the software configuration, and it automatically digitally marshals, meaning it connects up all those I/O points in a soft arrangement behind the scenes. So now you're ready for that final commission. So it really helps streamline and, again, remove the drama from all of the project things that we've dealt with in the past. And I've lived through that, so I think if you've done loop checks and some of the hecticness and the 24-hour days and trying to meet those deadlines, I think you know what I'm talking about. All right, so this is basically what I wanted to cover today. I wanted to cover how Select I/O can take automation off that critical path to project completion by supporting or decoupling of project tasks between that hardware and software, basically, so they can be done in parallel. The idea is the cabinetry, the standardized cabinets can be sent to site early without the electronics. They can be wired to, and then when the time is right, when you're ready, you can purchase and install the I/O modules, for instance, and all the other electronics that are needed. This is a much better way to go. And with this Ethernet I/O field kit, we can do all that work, right? We can do all that work ahead of time or when it's ready, all without the system kind of in place. So we can really decouple those project tasks between the software and the hardware. We can minimize the impact of late changes by removing the need for rework. Again, we're loosening up that design freeze so you can kind of get your act together a lot more. You have more time to do that. As well as once you do have the cabinets, we've done things with a single channel or granular I/O, so you can just replace one module at a time. We built in things to the system that usually maybe are separate wired type of components. So really, there's not really usually a need to do any kind of rework, or it minimizes the rework needed to more of a software basis, which really reduces change orders. Also, the fact that it's networked I/O solution, right? So that if I do need to move things around later, again, it's all behind the scenes in software. And promotes a true standardized approach that adds flexibility while reducing project costs. I think the idea is that this I/O system is very full-featured. It has all those bells and whistles to negate the use of all this ancillary hardware, and that's usually where the rework is needed, and also removes a lot of the again, the documentation needed and things. It's really the best way to go to have a very standardized approach. And Select I/O really leads or promotes that methodology. So some sources for information. It's all over the web. I recommend that you go to abb.com/800XA, which is for System 800XA, but that will get you to the main page for 800XA, and there'll be a big banner right on the front. You'll see, you can see it in the background here, where you have this hand as hand model, a professional hand model that we hired. With the module in place and the idea of standardized cabinetry, you select on that, you'll get to everything you need to know about SelectIO, including our safety offerings, our kind of the way we describe our parallel work processes is xStream engineering, meaning multiple work streams. That's in there. So all the information you could possibly want to know on this solution is there. We have something available on the web called 800xahardwareselector.com. If you just type that into Google or anything like it, you should get to this page. That kind of gives you you can go and then search for I/O systems. If you do a pull down list, you'll see SelectIO, and you'll see all of the SCMs available, all of the different hardware and the descriptions of those. And you can get data sheets and print them out, email them to yourself or to others. So that's a very nice handy tool to be able to use. And just go to YouTube and search for SelectIO, and you'll see great videos on this whole concept and what we're talking about here. So those are 3 quick sources of information that I think you should go to if you want more information. Or you can always call me or write to me, Roy Tanner at us.abb.com, and I give you my cell phone number there if you want to reach me and anything you want to know about this.
That's excellent. Thank you, Roy. Before we move to Q&As, I'd like to just take 10 seconds to share with our audience next week's topic on adaptive execution. Our presenter, Mr. Srinivasan, who's the Senior Director for Adaptive Execution Center for Energy Industries, will be talking about how ABB is evolving the traditional project approach to deliver results faster, even when faced with complexity and change. The session will be on December 8th at 11:30 Eastern and again at 11:30 Pacific, and we hope to see you there. Roy, I have quite a few questions, so we'll get to that right away. The first one is there an AI with heart?
Yes, there is. There is an AI. All of our analog SCMs have heart capability, not only to pass through the data into maybe some other packages, but also to bring in the secondary values right into the controller and stuff. So each one of the AI and AOs have heart capability. And again, if you go to the 800XA hardware selector, when you bring up those data sheets, all the data sheets are available for the different SCMs with all of the specs on there.
Okay, next question is there any software to select MTUs, I/O modules, etc., to make sure we have selected the correct modules?
Yeah, I think you notice with SelectIO, the MTU that we plug into is the same MTU for all of the SelectIO. So regardless if it's IS or safety or what have you, the MTUs are identical. It's really about there might be different GOs, the generic IO modules for safety and non-safety. There's different terminal blocks for IS and non-IS, but those all get plugged into the same MTU for SelectIO. Now, if you're talking our multi-channel solution, which is S800IO, we have other ones, but S800IO is one of our main ones. If you go to that hardware selector, it's really nice where if you bring up, let's say, an analog in module with 8 inputs, or 16 inputs, let's say, then you can actually scroll through. It will give you all of the termination units that go with that module. So you can go through and say, do I want the one with fusing or non-fusing, and maybe there's a redundant one. So you can have the capability to kind of go through those different selections and then also get the data sheet on those MTUs, those termination units for those multi-channel boards. So really go check out that 800XA hardware selector. I use it on a daily basis because I can't remember all of the different termination units for this IO module, and that allows me to go see those. We have, I think, 41 different flavors of S800 modules, and each module probably has 3 or 4 different different termination units that can be used with those modules. So it's a great resource.
Great. Next one is it possible to install remote I/O in a process area that's a hazardous area, for example, zone 2, without using an explosion-proof enclosure?
Yeah, I think this I/O can be installed in the C Class 1 Div 2 Zone 2 areas. We do have an I/O system also available that can go into the Zone 1, the Class 1 Div 1 areas as well. That's called S900. So we do have another I/O platform that's also in that hardwareselector.com, 800XA hardwareselector.com site. You'll see another I/O system in there called S900 that can be mounted or installed in those areas. But with our Select I/O, for instance, we can that can be installed in the Class 1 Div 2 area, but then reach those, communicate with I/O in those hazardous areas, and brought that up with our intrinsically safe modules and other hardware that we have available.
Perfect. Is the ring type topology supported through the Media Redundancy Protocol, MRP?
Mm-hmm. Yeah, so it's really flexible when you're using Select I/O on those head stations. You can use a daisy chain, you can use a redundant ring, you can use a star, ring of, I think one of the applications had a ring of stars. It's very flexible in the network solution that you want to do, and it does support MRP protocol.
Perfect. What are the standard Select I/O cabinet sizes? Number of I/Os was written in brackets.
Well, let me do the math here. I think Brad's on the line. Double check me if I'm wrong here, but I think there's 7 MTUs in our standard junction box solution. So I think right now we have 2 sizes. I think we have the full size. We have the medium, which has 7 MTUs, so 7 times 16 would be how many I/Os are capable in that cabinet. I think it's 7. It could be 6, but I'm pretty sure it's 7. There has been on jobs, if they want smaller, some people have wanted like 1 or 2 MTUs. I don't think we have a standard offering yet for those. I think that's coming, but those could be designed, like as a one design and then reused on the project. I have seen that happen. So out of the box from our divisions, I think we have 2. We have one that has a full-blown cabinet, which has multiple MTUs and maybe multiple head stations. So I'm going to say that has probably 14 to 16 MTUs in it. Brad, correct me if I'm wrong, like the full-blown cabinets, but the medium ones have 7 MTUs, so 7 times 16.
Yeah, I'll just add to that, Roy, and thanks. So the smaller cabinet, as you said, has 7 MTUs, but you can actually order it just with 3 because it's 2 columns of I/O. First column with the communication and then the 3 MTUs, and then the next column of 4. You can order just with 3, or then you expand it to the 7. So you get that flexibility of just 3 times 16, 48, and going up to the 7 times. But for a much bigger cabinet, we can go with the 3 clusters of 12, the time of approach kind of stuff. So we can cover all the needs of stuff, and if it's not needed, if it's something specific to a project, again, we'll give you the drawings and allow you to design a custom requirement that'll be your standard on your project.
And the full footprint is really, you're wiring directly to these things. They have terminal blocks. We also have grounding bars on this for the spare cords that aren't used and things. So there's a lot of good wiring capability on these, right on the MTUs themselves. So we don't have to have those full, all those terminal blocks, eating up all the footprint in the back and things. So the footprint is pretty reduced when we do this. Great.
I have 2 more questions here in the queue, so I'll keep going. First one is this I/O going to be compatible with older AC800M controllers?
Yeah, I guess I don't know if there's any controllers we're not compatible with. So the communications would be put onto those controllers, and I think other than probably maybe the smallest one, but anything that I know of can all be connected to the Select I/O offering. So I don't think there's any restrictions.
Okay, and from the same attendee, we have, how price competitive is this compared to current S800 or S900 I/Os?
Well, it is a premium offering. So there is going to be a cost adder for doing an individual networked I/O solution. Let me say this really quick, though. The S800 I/O line can be put on a we have a head station just like the ones for Select IO, and we can put our S800 IO modules on that as well. So you don't have the single channel granularity, but you do have S800 now that can be put on an IO network solution. So sometimes what we try to do is make sure that, do you need a Select IO type offering? This really promotes a lot of flexibility on large capital projects to reduce those change orders. It has a tremendous value there. If you know your IO count, if you know everything that's there, you can always use our S800 IO. And if you like the idea of having a network type IO solution, you can use S800 with that same kind of IO network topology. So as far as price competitiveness, obviously the Select IO is going to be more expensive than your S800 IO solution overall. But when you're looking at the overall, reduction in change orders and the flexibility that a single channel granular solution holds, and also the reduced maybe wiring and other things that you may not have to do now because of all those capabilities built into that IO. I think if you look at the overall project, we're seeing that the projects overall are making out to be less expensive by using this type of solution. But if you look at just the IO per IO, Select IO will be more expensive than the S800 IO solution.
Okay, and the last question, which I think is a great question to close this off here, and it kind of ties in here with cost. It's, can you elaborate on the cost savings from the perspective of an EPC?
Mm-hmm. Yeah, I mean, we'll just summarize it up based on how we laid out the presentation a little bit. If you look at the kind of the means by how we're going to separate off those project tasks and do all that work in the field, and again, allowing you to have more time and less maybe communications and coordination to have to do with other vendors. First of all, the biggest thing is probably that it really makes a remote IO solution achievable, where you can now take these standardized cabinets and this hardware and put it next to the equipment. Think about all of those wiring and cable trays and items, not to mention the documentation, the loop elementaries and loop diagrams that you wouldn't have to do because of the standardized approach, and documentation on all the individual cabinets and all that. So I would say that's your biggest thing for the buck. If you go back and look at this presentation, I put some dollar signs next to the areas I thought EPCs would save the most, and that would probably be the biggest one. Then there's change management. I think the reduction of change orders that you can do with this, I think sometimes those are hard to predict, but they do come up. I think in one example, somebody said, well, we needed to make some changes, and it was 20%. And I'm like, well, 20% is a pretty good number when they just had to when they had to add a controller and then move and redesign all the hardware to fit that new arrangement. Not to mention, there's always the new hardware that you have to buy. That you have to buy that maybe, but as far as all the rework and things, you're getting rid of that. So I think there's a good 10 or 15% savings right there off the bat for any kind of changes that come up. And then standardization. I mean, I think that one cabinet design, when you put it in, and you can have that flexibility to make changes, and it can accommodate those changes. That's why it's important to say that, yeah, we have standardized cabinets, but what happens when you change this to this? Do you have to add a bigger backplane? Do you have to add other hardware to the cabinet? That negates the whole thing of standardization. So just make sure you look carefully of these kinds of offerings. But there's a huge savings, in the standardization, just on documentation alone. So I'd say those are three of the biggest areas.
Great. Well, thanks again, Roy. And on behalf of the event organizers and today's presenter, I'd like to thank you for your participation in our lunchtime virtual chat on Select IO. Don't forget to bookmark the webpage that I put in the chat box so that you can go back to it, as we'll be adding more topics for the new year. Know that your feedback is also very important to us. If you have any topics that you'd like us to cover on the webpage, you will find a Submit Topic button. And please don't be shy, enter them there. And we wish you all a great day, and thank you, and stay safe.